Okay, yes, it's duplicated. It means they're sharing that seek pointer. Okay? So go ahead and set the child and the parent. All right, so the child sleeps one, and then both of them call read. So the parent's calling read first. So what's the parent getting? It's getting the capital C. Okay? And it's updating the seek pointer. So when the child wakes up, the child's going to read and the child's going to get the H. Okay? Now the parent waits, so now the parent's got to wait for the child to die. Okay? So child sleeps for a second, parent reads the C, parent now waits, child wakes up, child reads the H. Okay? It's not the child goes out and prints it out, so it's going to print the H. Before the parent prints the C, it's going to print the H. Child dies, parent wait returns, parent prints out the capital C. So the answer is, first line is H, second line is capital C. Shall we do a self-esteem check? Did I kill it? Where is it?
If you called open before you called, or after you called fork, would it be CC?
Yes. I don't know. Is that you, Henry? Yes. If the open call was after the fork call, then it would be CC because they wouldn't be sharing the file descriptor anymore. What happened to my? There it is. There we go. Reports. Okay. Well, 12%. We got a lot of stuff. Well, okay. How about the second one? Probably, I'm guessing it's going to be about the same, isn't it? No, a little bit better. Okay. Okay. Question 3. After writing the following program, how many lines are there in f2.txt? Okay. Calling it now, we're calling for write, and we're calling it with f open, so there's a standard I/O buffer associated with it that's backed up by a file. So when I call this fprintf, Fred goes into the buffer and not to the file. So now I call fork, now I got 2 processors with that buffer. Call fork again, I now have 4 processors. Sorry, 4 processes working with that buffer. All of them print binky. Then they close, that's gonna flush it. Okay? It's gonna flush each buffer. The underlying file descriptor is duped, right? Between all the fork calls, the underlying file. So when it flushes, each one appends. So the answer is 8. Each process will print Fred and Binky. Okay. %, the few, the proud. Okay. All right. We call alarm and then fork. The operating system will only, well, that's a nice thing to know. Okay, so if I call alarm and then fork, it doesn't deliver that alarm signal to multiple processes, just to one. Default signal handler has the process die instantly without calling exit, without flushing any standard I/O buffers. I have a feeling this prose is going to be relevant to this question. All right, so if we wait a few seconds after the following program exits, how many lines are there in f3.txt? Okay, open it, standard I/O, sharing a buffer. fprintf Fred, Fred's going into the buffer. Call alarm, okay. Now signal alarm is going to get delivered in a second. We call fork, signal alarm is only going to get delivered to the parent. Okay, so they both call sleep, parent's going to die, right? Because during that sleep, the alarm is going to be delivered to the parent process. It's going to die, not flushing any standard I/O buffer, so nothing. There's no output that comes from the parent. You'll get the prompt back, right? Because the shell's only waiting on the parent. That's why I say you have to wait a few seconds. A second later, the child will wake up. Child will go ahead and do the printf of binky, close. How many lines are there in f3.txt? Well, I think there are going to be 2. I think there's going to be a Fred and a binky, right? Because in the parent, Fred went to the buffer, but then the alarm call killed it and the buffer didn't get flushed. Yes, sir?
When you say flush, do you mean that the buffer gets put into standard out?
No, well, if it were standard out, but here, when I say it's flushed, okay, it's going to get flushed to f3.txt. Okay, so what does this do? fopen, it's going to open the file, so it's going to make an underline open call. So there is a file descriptor open there, but it's being held in this data structure. But then it also allocates a buffer, and this one goes to the buffer. And then down here, when I say fclose, that's when the buffer gets flushed. Okay, but it also, when your program exits normally, it flushes all the buffers as well, just because that's usually what you want. Okay, so the answer there should be 2. Self-esteem check. 2. Oh, look at that. All right. Very good. Shall we check previous years so we can hurt you again? Yes, we got a nod from Mr. B. Maples. What did we get? 25. I think killed you. 41. Do we really want to go on? Yes, we do. I mean, I said I like teaching you. Yeah, here we go. All right. 24. Oh, what were you? Were you better? 27. All right. You just got to wait. You all are question 4 people. That's what you are. Okay. Good. All right. Goodbye, turning point. Goodbye, that. All right. I'm going to just look at this program because there's no way I'm going to be able to write it. Although I can tell you I know where I was when I wrote this program. Do you all know that? Do you all like see a program and you know where you were when you wrote it? You're like, yeah, I was at my desk, Dr. Plank. That's where I was. Or I was on my bed. Well, some of us program every day of our lives, and we do it wherever we are because that way we're not responsible for conversation, right? If you're programming, especially if it's for class, then you don't need to generate conversation. Although in this circumstance, my wife had a gallbladder attack and got admitted to UT Hospital at 1 a.m. and didn't get out until 7 a.m. That's where I was when I wrote this code. I was in that waiting room, all alone. It's kind of a depressing place. And I couldn't really sleep, so I thought, well, let's just write some lecture notes, shall we? Okay. Sure. Let's take a look at circ, sigpipe 1. Let's see. This contains some. You're gonna make use of some of this information, by the way. So the idea here is we want to explore sigpipe. Not a bad thing to explore. Okay, so what I've got is I've got a string that has all the capital letters, and then what I'm doing is I just go into a loop where I call fput_s on that, so standard out library, and then I call fflush on standard out, okay, and then I keep doing it, and then I say which iteration I'm done. So I just keep doing this nonstop. So if I'm running this program as normal, right? So it's probably there. So if I say bin sigpipe 1. Okay, this program's going to run forever just doing that. Okay, very exciting. Now, why do we care? Well, what happens if I generate sigpipe? How do I generate sigpipe? There's one way, right? Because head is going to read one line, and when after it reads the line, it's going to exit, so that the end of that, the read end of that pipe is gone. So eventually, when this guy flushes into it, right, it's going to generate sigpipe. Okay, so that's fun, right? So it died on iteration 2474. Is that deterministic? No, it is not. Is that depressing? Yeah, a little bit. Okay, so think about what's going on. Now, let's think about the head program, okay? What's head doing, right? Gun to your head. You're writing head. What are you going to do? I'm going to call fgetS. Well, I'm going to write it in C++, okay? But let's say we were forced to write it in C, okay? I would call fgetS. And I would just call fgetS and I'd call fgetS and I'd count whenever I see a new line, because sometimes with fgetS you don't get a complete line. But I'd just keep counting, and then when I hit 1, I would exit, okay? Well, with this pipe, when does it read, what read call is being done under the hood here? When I call fgetS, what's the read call? It's going to read something around 8K, right? Because it's going to read into its buffer, okay? So it's coming from a pipe. Now, if it were coming from the terminal, it would do something. There'd be different things, but it's not, okay? Coming from a file, same thing. It's going to read 8K. So it's reading 8K, okay? So it'd be logical for me to think that, right, after 8K, writes had been written here, I would generate sig pipe, right? Because after 8K, it'll do the read, right? And then it'll die. Oh, so it could be non-deterministic. I'm trying to think of the non-determinism. But that can be non-deterministic too, because now, once it actually does that read, now this one's gonna start filling the pipe again. Okay? So this guy can write up to, so actually, you would think, God, it's crazy, that's iteration 113. Right, how big's that string? Right, that string is 27 characters, there's a new line in it, right? So let's calc 8092 divided by 27. Okay, so I would think that I would generate sig v between 303 and 606 iterations, right? Because that way I've filled the buffer, it's flushed the buffer, right? I'm refilling the buffer, head dies, and now the operating system says, okay, sig pipe. Okay? But you get that. So there's some stuff going on, right? Where maybe head is actually getting a partial read, right? It's not, even though it's saying read 8K, the operating system's probably saying, I don't have 8K, but I got like 2K. Here, have it. Okay? The point I'm making here is that all this stuff is deterministic and or non-deterministic, and it is made worse by buffering. There's buffering here, and there's also buffering in the operating system. So actually there's 2 levels of buffering going on here, which is why you have a hard time making any sense of when sig pipe is called. This is what I'm trying to communicate to you, is that you can't make any reasonable sense that if I got sig pipe, something happened besides something happened, that file descriptor got closed on me. Okay, but I don't know how much got written, read, won't know. Now here's the good part, is that fprintf and fflush, I have it here, both have return values, okay, which I've tested here. Now let's suppose I write a signal handler here for sig pipe. So signal, sig pipe, pipe handler. Terrible piece of code. Okay, so void pipe handler int I. Right, and I can set a print. I'll say printf. Call it sig pipe, and then I'll just return. Okay, if I go there, uh-oh. Oh, God. Y'all are tired. That or you're not telling me things. Which is it? You're nodding. Number one, you're tired. Okay, I get it. None of you were thinking that's wrong?
I thought I remembered your previous handlers not having the parentheses, but
You,
was not.
you didn't have the temerity, the confidence to say, Dr. Plank, you're wrong.
Pretty much.
Because you knew I'd rip you a new asshole. No, I wouldn't. I'm so damn nice. People don't think I'm nice. Do you all think I'm nice? Don't answer. No. No, Mokshi's just like, no. Fine. He's like, I've taken you 4 times. No. Did I tell you about most courteous professor? Yeah. Never win in that. Unless you make me look like Van der Zanden or Barry or one of the nice people. Okay. All right, so we're going to run this one, and now we're going to pipe it into head-n1. Oh. Did I call make? Did it not tell me about the signal? Oh. There we go. Okay. It's interesting. I didn't get the printf. I'm not quite sure why I didn't get the printf. Let's try it again. Oh. You're all tired. Why didn't it say caught sig pipe? And where's it going? On the pipe. So I gotta do this to standard error. When y'all are writing code and something seems wrong, you should look into it. You shouldn't be like, maybe it's okay. It's not. There's usually a reason. There we go. So there, it said it caught sig pipe, which is very nice. Okay, and then, so the nice thing is that the standard IO library has been set up so that if one of its things generates sig pipe, it'll die and return, and you catch the sig pipe, okay, and ignore it, now you get a return value either on the fputs or on the f+. You'll actually get an error, okay? So this is good because you are gonna write code where you have to deal with this. You're gonna write a chat server, okay? And your chat server has to know when its clients have exited. And one of the ways that it might know the client has exited is it writes bytes to the client who's no longer there, and so that'll generate sig pipe. You don't want it to kill your server. Instead, in your server, you'll ignore the sig pipe. Yeah, you'll ignore sig pipe, and then you'll actually read the return values of your standard IO calls, and that'll let you know my client's gone away. Good thing to know. I had something else. Sorry. Oh yeah, I got that. All right. Yeah, two things. One, and you might have to be a certain age for this, but people, they still use NFS. Okay? Here's something that often is not a bad thing to do. Seg fault handler. You know, you go ahead and do this in your code. All right, here you go. fprintf, standard error, NFS, not responding, still trying. All right, and then in your main code, you do this, sig segv. So what does this mean? So what it means is that if I've got a seg fault in my code while I'm demoing it, rather than having your code crap out with an error that says it has a seg fault and then you look like a chump, instead, it'll call the alarm handler, and then it'll say that the network file system is not responding, and then it'll hang. And if you're really smart, then what you do is you go through and you disable every other signal so that you can't kill your program. Because with NFS, when it happens, you can't kill your program. So, smart thing to do with your demoing, because whatever you demo, you're gonna seg fault. All right, that was one. Now, number two. Okay. Comments, children. All right, so what we have here is that we've seen this program before, right? We're taking J and I and we're doing this loop, and then we're going up here and we're printing out how many seconds. We're printing out every second what has happened. So I put a little more smart stuff into the code so that you can see the number of seconds. So here, so, right, and you know, I see I even got that right. Does that bother you whenever you see that? You're like, come on, really? Yeah, you just make your print statement so it doesn't happen, right? Number of seconds, colon, done. Okay. All right, now, let us suppose I call this with optimization on. So let's say gcc-03 circ sh3.c. Okay? So a.out. That was fast, right? That was really fast. Do we think that the compiler was so good that it made this loop really fast? I mean, how many times is this loop iterating? It's 1,000,000 times 5,000. So that's 5 times 2 to the 30th. That's a lot, right? Right? If our machine's hanging along at 2 gigahertz, it's still gonna take a second or two to finish this loop, okay? So something's going on. Well, what's going on? The compiler's smart, right? The compiler looked here and it said, well, this loop doesn't do anything, so I'm gonna delete it. So, okay, we can try to make the compiler, try to make things smarter here. What should we do? Let's see how smart the compiler is. So int k, let's say k equals 1 minus k. We'll put that in the inner loop. All right, so do you think the compiler can figure it out? Can you figure it out? What is k gonna be? Well, considering I never set it in the first place, we don't know what k is gonna be. So here, k equals 0. Okay. Right, so in the first loop, k will be 1, second loop, k will be 0, right? Third loop, k will be 1. So what's the final value of k? Please. If it runs an odd number of times, it'll be 1. If it's an even number of times, it'll be 0. Is this loop running an even or an odd number of times? How many powers of 2 are in this term? Quite a few, at least 9. So I think it's even. Okay, so the question is the compiler smart enough to figure this out? Shit. Well, I didn't print it out. So the compiler might not have been smart enough to figure it out. The compiler just knew I wasn't printing anything. Let's try that. Ha! All right, good. I was smarter than my compiler for once. Okay, so that's awfully nice. But that doesn't seem right, does it? So what's going on, and this is unfortunate, but it's a fact of life. Compiler optimization, the theory behind compiler optimization is the compiler can do anything it wants to your code, anything, as long as it gets the right answer. It gives the right output. And by the way, signal handlers don't count, okay? So what's happened? Well, it's not allocating I and J, or maybe it is actually allocating I and J in global memory, but it's never writing back to global. What it's doing is it's putting I and J into registers, and it's never storing the values of those registers until the very end. It'll store K. Okay? So that makes it fast, right? And faster than having to go memory. But the problem is now is that I've got an issue, and then my signal handler is not working. Okay? So how do I deal with that? It's horrible. I hate this keyword more than anything because it makes no sense to me. You say volatile. Mr. Scribes, can you give me a reasonable explanation of why that word is volatile?
So it's like, the purpose of volatile is so that the compiler doesn't do optimizations for multi-threading or situations like this. It basically just means that it can change. You can't depend on it being like acting like a normal variable. Like, because say if I have a volatile int in a function, and the compiler looks at that function, then it says nothing in this function changes it. If it's marked volatile, then the compiler says, okay, maybe something else in another thread or in another signal handler or whatever is going to change it.
So I bet so it's the same thing. Actually, is what's going on here, right? Is another thread might be changing it, so I can't dump it in a register and not write it back to memory. But I still don't understand why volatile, right? To me, what does volatile mean? Well, I mean, it means you lose your temper easily. But like in chemistry, did you all take chemistry in high school? Right? What did volatile mean? Well, it meant it evaporated quickly, right? So it seems to me if you're saying it's volatile, it means it might evaporate quickly. I don't understand the metaphor behind it. Okay, but what Mr. Squire says is right, and the key is it's not going to store. When you say volatile, what it means is whatever that changes is going back to memory because I don't know what's going on externally to it. Okay, does that slow your program down? Hell yeah. Kills it. All right. Yep. Back to crap. Right? So, but it's something you should know, right? Is that if you're messing with this stuff or you're messing with signal handlers, optimization off. Well, but the thing is often when you're doing this, you're doing it for debugging. Like I'll use signal handlers for debugging sometimes because my code's too big and spindly. That just gives me a way of accessing it. Okay, I'll turn optimization off and that way it'll work. Okay, since we have the time, I could just let you go, but what fun would that be? Do we all know what this week is? Have one person tell me what this week. Why is this week special? There we go. Can you not wait? I can't wait. You're like, what is that? It's a golf tournament. It's one of the 4 best, and it's the best of the 4. Love the Masters. And so, in 2021, the year after COVID, so my son, so this is what happens. My son shits gold. Okay, do you know people who just shit gold? Right? Every time they turn around, something good happens to them. That is my son. And so he works with someone who actually volunteers at the Masters every year. You've got to like kill someone to volunteer at the Masters. It's not like you say, hey, I want to volunteer. No. His dad played football for Georgia, so that's why that happened. And he's a stockbroker, so he takes his clients, so you get 2 practice tickets for the Masters if you volunteer every day. There's practice Monday, Tuesday, Wednesday. And so Jeff told JC, Jeff being the son, that if one of his clients ever cancels, he said, I don't care when it is, it can be the night before, let me know, I'm driving to Augusta. So 2021, we get a phone call like the equivalent of last Wednesday from Jeff saying, JC got me the tickets, one of you can go with me. You know what happened? I taught my class on Zoom from the Airbnb while my wife went to the Masters. So I've never been to the Masters, which is sad. Have you been to the Masters?
No.
Someday.
It's like a $10,000 ticket.
South Carolina
It's-
does like a work program. There's a class you can take at South Carolina, and then if you're part of the class, you work the Masters and make a good amount of money and they get to go.
I should enroll. It's my only way of going. $2,500 right now a ticket a day. So it's a $10,000 for the week. It's $1,500, and then getting lodging. So.
If you win the lottery, you can buy it, right?
Well, no, that's like on StubHub. Now, if you win the lottery, you'll get to go. And I know so many people who have. You see people at Augusta, it's like, did you go? Yeah, I won the lottery. Dick. But I'm a happy person. Okay, sorry. Anyway, starts Thursday. If you don't care about golf, whatever. It's less depressing than watching UT lose at basketball. What am I doing? Oh, okay. This is a fun little program here. So, here's what I'm doing. I'm doing what I'm going to call poor man's threading. Now, we'll teach you regular threading here in a week or 2. Okay, but what I'm doing is I'm going to have a program that is going to oh God, I'm using rand. Okay, it randomizes 2 arrays, okay, with the same numbers, and then with one of them it runs selection sort, and the other one it runs insertion sort. And then what it does is up in an alarm handler, it has a global variable there called switch algorithms. And so every second it'll switch the algorithm from insertion sort to selection sort, right? So here it is. Which one is that? That's cheating. I should have named my things where I should have made you figure out which sorting algorithm this is. I could be wrong. No, this is selection sort. Right? Selection sort. Could we write selection sort in our sleep? Uh-oh. They're like, no. Right, selection sort. What are we going to do? We're going to find the best thing, swap it. All right? Find it, swap it. But up here in my while loop, I also check and see. I check and make sure that switch algorithms is false. Once it's true, this while loop drops out, okay? And now I go to this one, and now it's going to use insertion sort. There's that great insertion sort loop. Oh, that's a horrible loop. Okay? And then when it's done, this must all be in a while loop. Yep. So while neither one of them's done, no, so it's nice. It's poor man's multi-threading. It's kind of cute, all done with an alarm handler. So let's run it, and then we can all leave. And sort compare. Size, how big? What do you think? Do you think selection sort will even finish with 1 million elements? All right, so every second it tells you the indices. So insertion sort has a chance of completing, whereas selection sort, man, that's slow. I like how the index is going up by 1. What do you think's going on there? I think there's a bug in this code. Okay. It'll never finish. Here, let's do less. Now it'll finish. Done. Okay, now we do one more. There we go. It's gonna finish. That's so weird. I don't understand these values, but I'm not gonna look into them. Okay, questions? Are you gonna need to know what signals are? Yes. Are you gonna use signals ever in your program? Yes. In your chat server, you are going to catch SIGPipe. So you need to know. Will I need to know them for the exam? Yes. So all of those things. Are they straightforward? Yes. There's nothing too subtle with signals. Okay, have fun. I'll see you all Thursday.